Determine all values of c that satisfy the conclusion of the mean value theorem for the function f of x equals x to the fourth plus 4x cubed minus 2x squared minus 6x minus 3 on the interval -4 included to 2 included. The first thing to do is to determine whether the two conditions are met for the mean value theorem to apply. The first condition, the function f of x, which is x to the fourth plus 4x cubed minus 2x squared minus 6x minus 3, has to be continuous on the closed interval given. X to the fourth plus 4x cubed minus 2x squared minus 6x minus 3 is a polynomial. And a polynomial is continuous on any interval. Therefore, it will be continuous on the closed interval given. Closed means that it includes both endpoints, indicated by the square brackets on both ends. So condition 1 holds true. Condition 2, the second condition, is that the derivative, which will be first term power rule, bring down the power, subtract 1 from it. Second term power rule, bring down the power, multiply it with the 4, subtract 1 from it. Third term power rule, bring down the power, multiply it with the -2, subtract 1 from it. Fourth term, constant times x, derivative will be the constant. Fifth term, constant with no x, derivative is a 0. The derivative has to be continuous, it's called differentiable, on the open interval. 4x cubed plus 12x squared minus 4x minus 6 is also a polynomial. And a polynomial is continuous on any interval. Therefore, this will be continuous. It's called differentiable for the continuity of the derivative on any interval, including the open interval. We want it to be the open interval always for differentiable because the derivative technically doesn't exist at the endpoints of the interval. The open interval means that it does not include the endpoints, indicated by the round brackets on the endpoints. Condition 2 also holds true. Since both conditions hold true, the conclusion of the mean value theorem applies here. And that is, the slope of the tangent line at some value c will equal the slope of the secant line connecting the two endpoints, f of b minus f of a over b minus a. And this will be true for at least one c, maybe more, in the open interval of -4 to 2. The interval in this problem is -4 to 2. The left endpoint, -4, is the a value. The right endpoint, 2, is the b value. So this right side will be f of 2 minus f of -4 divided by 2 minus a -4. The left side, f prime of c, can be evaluated by plugging c into f prime of x, giving 4c cubed plus 12c squared minus 4c minus 6 equals to the right side, f of 2 minus f of -4, each of those can be evaluated using f of x. F of 2 will be 2 to the fourth plus 4 times 2 cubed minus 2 times 2 squared minus 6 times 2 minus 3, and then minus f of -4, -4 to the fourth plus 4 times -4 cubed minus 2 times -4 squared minus 6 times -4, and then minus 3. This entire thing divided by 2 minus a -4, which is the same thing as 2 plus a 4. So 4c cubed plus 12c squared minus 4c minus 6 equals to 2 to the 4th is a 16, plus 4 times 2 cubed is an 8, minus 2 times 2 squared is a 4, minus 6 times 2 is a minus 12, and then minus 3, minus negative 4 to the 4th. Negative 4 times negative 4 is 16, times another negative 4 is negative 64, times another negative 4 is a positive 256, plus 4 times a negative 4 cubed, which is a negative 64, minus 2 times a negative 4 squared, which is a positive 16, minus 6 times a negative 4 is a positive 24, and then minus 3. All of this divided by 2 plus 4, which is a 6. So this equals 16 plus 4 times 8, which is a 32, minus 2 times a 4 is a minus 8, and then minus 12 minus 3 is a minus 15, minus 256, a positive 4 times a negative 64 is a negative 256, a minus 2 times a 16 is a minus 32, and then a 24 minus a 3 is a positive 21. All this divided by 6. So 4c cubed plus 12c squared minus 4c minus 6 equals to 16 plus 32 is 48, minus 8 is 40, minus 15 is 25. And then minus 256 minus 256, those will cancel, and then minus 32 plus 21 is a negative 11, divided by 6. 25 minus a negative 11 is the same thing as 25 plus 11 over 6, and 25 plus 11 is 36 over 6, which reduces to 6. So we have 4c cubed plus 12c squared minus 4c minus 6 equals to 6. Since we have a polynomial on the left side involving c, we're going to want to equate it to 0, so let's subtract 6 from both sides. So 4c cubed plus 12c squared minus 4c minus 6 minus another 6 will be minus 12 equals to 0. Since this is a 4-term polynomial, it can be factored by possibly group factoring it. We can group together the first 2 terms and look for a common factor, and group together the second 2 terms and look for a common factor. So the first 2 terms, 4c cubed plus 12c squared, and then the second 2 terms, minus 4c and minus 12. The first 2 terms have a common factor of a 4 and a c squared, and if we factor that out, that'll leave a c plus a 3. The second 2 terms have a common factor of a negative 4. If we factor that out, that will leave a positive 1c and a positive 3. And since each of these made a c plus 3, group factoring is possible because that c plus 3 can factor out of the entire remaining expression. And if we factor it out, it will take it away from both these. That's what will be left. The 4 can also factor out with it. And if we factor the 4 out as well, it will take out all of this and leave that as a 1. So it looks like it'll be c squared minus 1 left over. Which means we have a difference of squares, which can factor into c plus 1 and c minus 1. So since this is equated to 0, we can have the C be a -3, the C be a -1, or the C be a +1. We only want to keep those that are in the interval for the conclusion of the mean value theorem. The interval -4 to 2, not including either end. And it turns out each of these are in that interval. -3 is in that interval, -1 is in that interval, and 1 is in that interval. So we end up with all three of them. There's our values of C that satisfy the conclusion of the mean value theorem.